Hello, everyone. So today we're going to be talking about making solar the future. So today is Friday, April 8th, 2022. Here are my group members.
Hi, I'm Matin Nasab. I'm a civil engineer student.
Hello, my name is Ayub Muse. I'm an electrical engineering student.
My name is Nicholas Semyanov, and I'm an electrical engineer student.
Hello, my name is Ashur Khan, and I'm a mechanical engineering student.
Hello, my name is Arvin Miranayat, and I'm a civil engineering student.
All right, so in the introduction, we will be going over what is solar energy, how to capture solar energy, the composition of materials, and energy storage. And in the picture, it is the solar panel installed on some roof tiles. So what exactly is solar energy? Solar energy is the energy the sun gives off in its forms of rays, which are electromagnetic waves. Using this, we can capture the energy through either solar cells or concentrated solar power devices. Solar cells are usually made up of silicon, and there's research on more efficient material called perovskite. So in the background, we'll be talking about the history of solar cells, fossil fuels, and ecosystems. And the picture beside in the slide is talking about transitioning from fossil fuels to renewables. So how did solar cells actually start? In 1839, a scientist named Edmund Becquerel experimented with silver chloride and an acid and light together. Then later in 1883, Charles Fritz made a practical cell, which was made of selenium coated with a thin layer of gold, which had an efficiency of around 1 to 2%. So how does this relate to fossil fuels? Fossil fuels being a leading cause of global warming, we started to improve our cells till today being more and more efficient, leading to more products being available as carbon emission taxes were starting to discourage fossil fuel use. Fossil fuels are ruining our ecosystems, our lifestyles, but at the same time, solar panels and solar cells may also do the same, but to a lesser degree as they are historically placed in large areas that ruin the ecosystems they are placed, as well as the materials that are needed to build these cells may be mined at efficient or even unhealthy to the environment means. Currently, we are using other renewable sources such as wind turbines, which are hydro, water turbines, which are hydro, wind turbines, which use the wind, and nuclear reactors. All these sources are hazardous to the environment and have negative stigmas involved. In addition to this solar cell has the highest potential of generating the most energy, as it is receiving energy directly from the sun, which is basically our infinite source of energy. This follows and supports the idea of trophic levels from an ecosystem perspective.
When we think about solar energy, one question comes into mind: efficiency. In particular, how to make solar energy more sustainable. Key factors like scope perspective, sustainability, and efficiency all play a major role in solving this question. As we proceed to the next few slides, you will see their significance and how they work in tandem with the mechanics of a solar cell's photovoltaic ability.
As we're receiving more reason every day to use more renewable energy, so I'm going to take a moment and talk about the mechanism and how the photoelectronic effect can be more efficient. In order to discuss the solution to solar cell efficiency and the energy storage, we must take into factor the traditional design of silicon solar cells. The mechanics of a traditional solar cell involve capturing light by a process known as the photoelectric effect. The phenomena involves the release of electrons from a metallic plate after being exposed to a high energy wavelength. In order to utilize this process to its fullest, we must add trace amount of impurities to the silicon structure. And the two effects to make it more efficient, one of them is the material that we use, and the second one is the storage that they take. For the material, as my friend said, the perovskite materials can be efficient by 25.2% rather than the silicon. But since it's under the research, and also we need to use less storage, so we can put more panel in any space that any potential users that's going to use. So the lightweight lithium ion cells, they take so much less space than the batteries that we are using now. So in any space, we can put more lithium ion cells, and with the perovskite cells, we can have a 25% more efficiency. So we have less space and more efficiency by each panel.
Talking about discussion, we're going to talk about 4 different factors: how stable the cells are, what the rate of the decaying is, and what the commercial benefits of this are, as well as how efficient they are. So we're going to, I'm going to say for this, the perovskite tandem solar cells are made of composite materials of metal halides. This makes them unstable, and is also the reason why they are not conveniently in public access. NREL research has shown that solar panels have a median degradation rate of about 0.5% per year, but the rate could be higher in hotter climates and for rooftop systems. They are less expensive to produce, and this is the reason why they are a serious candidate for future solar energy resources in long term. Perovskite solar cells have shown a remarkable increased conversion efficiency of over 25% today.
So, in conclusion, to solve the energy crisis, the effort of engineers and marketers are needed to make solar cells more desirable to consumers. We can brainstorm potential ways to make the systems more attractive to the general public, and in doing so, we will contribute to the global goal of sustainability. Also, high efficiency and effective energy storage are goals that we must aim for in order to reach sustainability. Thank you for watching, and these are the references that we used.